Okay, so the whole next series of lessons is going to be on graphing quadratics. And before we even start doing that, one of the essential things that we have to know is what is a quadratic supposed to look like? If there's no shifts or no stretches or anything weird going on with it, what's it supposed to look like? So here's what a quadratic is. It's graphing that. So one of the things that we want to be able to do, that's called the parent function or just the base function. And the parent function means we're going to do things to that. So one of the things that we have to know, one of the things we have to memorize is what does the parent function look like? Okay, well, one way to get that is to make a little table, and let's take a look. So I'm going to pick some values for x, like 0, and stick those up into that equation and see what it is. So if I put a 0 up there, 0 squared is still 0. So if I plug in 0, we get back 0. But what about 1? If I take a 1 and plug in there, okay, when x is 1, 1 squared makes y 1. Okay, I'm going to try negative 1. Okay, I'm going to take negative 1 and put in there. So we have, let's just be careful here. We have y equals negative 1 squared, like that. I put the negative 1 right there. Okay, that's positive 1 again. So 1, when we stuck in 1, we got back 1. When we stick in negative 1, we get back 1. What about 2? Okay, if I stick 2 up in there, we get 2 squared, so that's 4. And if I stick in negative 2, okay, I'll put negative 2 in here. Okay, if I stick in a negative 2 times negative 2 is actually positive 4 again. So both the positive 2 gives us a 4 and the negative 2 gives us 4, and then I'm going to try 3. If I take 3 and put it in there, 3 to the second power is 9. And if we put a negative 3 in there, negative 3 times negative 3 is also 9. Okay, so we have to know these points. If we plot them, okay, 0, 0 is right there. Then the next one was 1, 1, so over 1, up 1. And then the next one was left 1, up 1, so left 1, up 1. So I went 0, 0, right 1, up 1, left 1, up 1. And then we start with a 2. 2 squared became 4, so over 2, up 4. And then we went left 2, up 4. So we went 1, 1, and then we went 2, 4. And then these last 2 points are 3, 9. So if I go over 3, 1, 2, 3, and then up 9, there's 8, 9. And over 3, up 9 that way. Now, of course, the next one would be 4, 16. It's just whatever we plug in, we get it back squared. So negative 4, 16. So whatever we plug in, we get it back squared. So 4, 16 is way up here. And then if we plug in 5, we'll get 25. So it's a parabola. Okay, so that's the basic parent parabola. Those are things that we have to be able to put into practice. Now, a couple things that I want us to notice. It all starts at this vertex. It's all from this 0, 0. From the 0, 0, we went over 1, up 1. Over here, it doesn't matter where the vertex is. So let's just say the vertex is right here somehow. Okay, so I've got this center point is now right there. Okay, over 1, up 1 is the next dot. And over 1, up 1 is the next dot. So these 3 locations, once we find the center, we have to be able to understand what these 2 are doing. They're going over 1, up 1, and over 1, up 1, left 1, up 1, right 1, up 1 from the center. So left and right, up 1. To get to the next dot, we went over 2, and then we went up 4. So 2, 4 from the new center. 1, 2, 1, 2, 3, 4 would put it right there. And 1, 2, 1, 2, 3, 4 would put it right there. And then the next dots of the parents were over 3 up 9. Okay, it's always going to be over 3 up 9. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. It would be right there. And then go 3 the other way, and up 9 would be right there. So there's the parent function, just starting at a place that wasn't quite at 0, 0. So wherever the center is, we need to know that the next dot is over 1 up 1, and over 2 up 4, and over 3 up 9. So if it started over here, the next dots are over 1 up 1, over 1 up 1. The next dots are over 2 up 4, 1, 2, 3, 4, and over 2 up 4. And the next critical points are 3, 9, over 3 up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's kind of like slope, but it keeps changing. See, here it was 1 to 1, then it was 2 to 4. Now it's 3 to 9, and 3 to 9. And then if we wanted, the next one would be 4 to 16. 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we actually know where the next ones are, and then over 4 up 16. Although you usually, 16 is kind of a big number. You don't usually have to go that far. The next one would be 5, 25 from the new center. So wherever the center is, we're going to go over 1 up 1, over 2 up 4. So if our center is right here, over 1 up 1, over 1 up 1, over 2 up 4, over 2 up 4, and so on. So right there is the general sketch of that parabola. Okay, so that's something that we have to know. Okay, there's some space down in here because there's a few more things I want to remind you of. So some of those things are what does inverse mean? So I want to remind ourselves what inverse means. There's two kinds. We have additive inverse. Additive inverse means we're trying to force 0. Multiplication inverse means we're trying to force positive 1. Okay, so if I have a package something like this, so for additive inverse, I'll put some examples over here. If I have a missing thing and then I have a -3, we're trying to force 0. That means this inverse right there has to be 3. So if it was given a -3, the additive inverse is a +3. Multiplicative inverse is something times 3 to force 1. So that means it would be 1/3 times 3 forces 1. Okay, so we're going to have things like this. We're going to have things like x minus 7. Okay, that means, so the inverse of that is 7, because we're forcing this to be 0. And there will be other times when we have something like 7x. And the inverse of that will be 1/7, because I'm trying to force 1. So 7 times 1/7 will be 1. Over here, 7 minus 7 will be 0. So here, if it's an addition kind of problem, addition or subtraction, we want to force 0. If it's a multiplication kind of a problem, we want to force 1. Okay, why am I showing you that? Let's take a look at number 3. This right here, that power, means it's a parabola. It's a quadratic. It's going to look like this. It's gonna look like a parabola. It's this shape. Now, all of these other numbers on there move the shape around. So it puts it over here or down here or maybe over here. So the first thing that we want to be able to do is figure out where is the new center, and then from there we'll just go over 1, up 1, over 2, up 4, over 3, up 9, and we have the whole thing graphed. Okay, well, it's the inverse of that. So we want to, here's the y package. This is the y shift. Okay, so it's an addition kind of a problem. So the inverse of that is -4. So the shifts are always the inverse of the package. So the y package's shift has an inverse of -4. The x package shift has an inverse of +3. Okay, the shifts are always the inverse of the variable. So that's the new vertex now. The x is 3 and the y is -4. So I'm going to put that down here. It's called, I'll put it someplace, let me zoom out so we can see a little bit more. So that's the vertex. I'll put it like this. The vertex is at 3, -4. So that V stands for the vertex. Vertex is the point where it makes the loop. It's the most bottom part of the parabola. Okay, so I'm going to put a vertex at 3, -4 because that's coming from the inverse. Okay, 1, 2, 3, and then 1, 2, 3, 4. It's right there. Right here was the 0, 0, so. Okay, now we just know the rest of it. From there, we go over 1, up 1, and over 1, up 1. And then over 2, 1, 2, up 4, 1, 2, 3, 4. So right there's the next one. 1, 2, 1, 2, 3, 4, and there's the parabola. Now extend it beyond these points because it goes on forever, because of course the next one would be over 3 up 9 and then over 4 up 16, so that goes on forever. So to get the new vertex, we just do the inverses of the x package and the y package. So right here, here's the y package. The inverse of that is 2. Here's the x package. The inverse of that is 3. Okay, so the vertex is at 3, 2. The x inverse was 3, the y inverse is 2. So right here's 0, 0. So the vertex is at 1, 2, 3, 1, 2. So there's our vertex. And then the other parts we have memorized. From there we go over 1, up 1, and over 1, up 1. And then over 2, up 4. 1, 2, 3, 4, and 1, 2, 1, 2, 3, 4. And that's enough for me to get 5 points is usually enough to get the shape of the parabola. And there it is. So to find this new vertex, we find the inverses of the y packages and the x packages. Okay, then sometimes there are multipliers on here. So first of all, here's the y package. Let's forget about that negative right now. Here's the y package. The y package, the inverse of that will be 1 in the x package. The x inverse will be 4, so there's the vertex. 4, 1. Okay, so I'll put that on there first. Here's 0, 0 right here. So 1, 2, 3, 4, 1. Right there's the vertex. Okay, but this problem also has a multiplier on it. You see how there's that negative right there? That negative is being multiplied onto the y's. Now just a negative, it implies there's a -1 there. So I have a multiplier on the y's. There's no multiplier on the x's, there's only a multiplier on the y's. So the y's are all going to be multiplied by the inverse. So I need to make something, what's the multiply inverse to -1. Now remember, multiply inverse is trying to force +1. So I need a -1 times something that makes +1. Well, it's another -1. If I have a -1 and I want to force it to be a +1, I have to multiply by another -1. So that negative means the y inverse is -1. So all of the y values are going to be multiplied by -1. Okay, so we have our vertex right here. We got that from the additive inverse. Now all the y values are going to be multiplied by -1. So I'm gonna draw this in another what should be. I'll draw the red in the normal one. Normally, we start at the vertex and go over 1, up 1, over 1, up 1. Then we go over 2, up 4, and over 2, up 4. So the original parabola then would have looked like that in the red. There's the original one. But all of the y values have to be multiplied times -1. The y values are multiplied times -1. So instead of going over 1, up 1, the up 1 is getting multiplied by a -1. So really so in our mind, this was the vertex originally, it's just been moved, but I'll think of it as 0, 0. Then we went over 1, up 1. But the y value is being multiplied times -1. So instead, well, let me put down what we would do in the first place. We'd go over 1, up 1, that would be this one. Then we go left 1, up 1, that would be like this one. Then we go over 2, up 4. Then we go left 2, up 4. See, these are the originals. Okay, but now we have to take all the y's times -1. So what's going to happen, taking this one times -1 keeps it at 0, 0. So the vertex didn't change, so that black dot's still going to be there. But now all of the rest of them, the y's are going to get multiplied by -1. So nothing happens to the x, but the y gets multiplied by -1. Here, nothing happens to the x, but the y gets multiplied by -1. Here, nothing happens to the x, but the y gets multiplied by -1. And nothing happens to the x, but the y gets multiplied by -1. Here are the new points. See how I just turned them all upside down? Instead of going over 1, up 1, we're going over 1, down 1. So from our new vertex, over 1, down 1. And then this one, left 1, down 1. Here we'll go over 2, down 4 from the vertex. 1, 2, 1, 2, 3, 4. And then the other one will be over 2, down 4 on this direction. And here comes the correct answer. So the black one, it's been shifted over 4 units to the right, 1 unit up for the vertex, and then it got multiplied by -1, turning it upside down. Now remember, the original one would have been way over here, starting at 0, 0, over 1, up 1, over 1, up 1. So like that, this is where it was originally, the parent. Then the 4 ones slid it over and up to there, and then that negative turned it upside down. So number 6, those similar things are going to happen. Here's the new vertex. Here's the y part. That's going to be at -3. Here's the x part. That's going to be at +1. So our vertex is going to start at -3, 1. So it would have been, and so I'm going to do several different ones now. Here's the original one. 0, 0, 1, 1, 1, 1, 2, 4, 2, 4. So I'm going to make this in dashed lines. That's the parent. That's just plain old y equals x squared that we started with. Okay, step one is the vertex is going to slide it over. So the parent is getting slid left 3, up 1. So I'm going to pick this dashed line up, go left 3 and up 1. So 1, 2, 3, up 1. And then from there, over 1, up 1, over 1, up 1, over 2, up 4, over 2, up 4. So there it is with the shift. The red one now has applied that. Okay, but notice we have not done anything with the 1/2 yet. So we have a multiplier of 1/2 on the y's. Okay, well the inverse of times 1/2 is times 2. So remember, multiplicative inverses are always trying to force 1. So 2 times 1/2 is getting forced to 1. So what's happening to the y's, they're all getting multiplied by 2. So the y values are all going to be times 2. Okay, I want to give you a couple ways to think about this. Y's are height. Y's are how tall it is. So what it means is it's twice as tall. All of the up and down dots are times 2. Well, that's actually enough for most people. If I start right here at this 0, 0, at this new shifted vertex, instead of going over 1, up 1, the ups are getting doubled. So every time I would take the normal thing, it's going to be times 2. So over 1, up 1 is really over 1, up 2. Over 1, up 2. This red dot that was over 2, up 4, the up is getting doubled. So it's going to be over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 2 the other way, up 8. And there's our new parabola. Now it looks like it got thinner, skinnier. Well, it kind of did, but usually what really was happening was the multiplier, the stretch number was on the y's, so we typically call that taller instead of skinnier. Because what we really did was we affected the y's, we affected the height. We took the red one and stretched it taller. So that's one way to think of it. All the heights just got doubled. So when we're doing it, if you know what it should have been, it should have been over 1, up 1, the ups got doubled. So over 1, up, double. Over 2, up 4, but the 4 got doubled. So you can think of it as a picture. Now some people don't do pictures well. So if you don't do pictures well, take the ones, take the main, you still have to know what should happen. It should start at 0, 0. Then we did 1, 1, negative 1, 1. Then we did 2, 4, and negative 2, 4. But now all of the y's are going to get times 2. Okay, so all of the x's are going to stay the same. So 0, 1, negative 1, 2, and negative 2. But all the y's now are going to get doubled. So if I take 0 and multiply it by 2, still 0. If I take 1, multiply it by 2, it's now 2. 1 times 2 is now 2. 4 times 2 is now 8. And 4 times 2 is now 8. This is the new pattern. We're going to start at the vertex. Okay, there's the vertex. Then I'm going to go over 1, up 2 from the new vertex. See, over 1, up 2 gives me that same dot. And then left 1 from the new vertex, left 1, up 2. Left 1, up 2 gives me that dot. And then over 2, up 8, that's what that's representing. And then over 2, up 8, that's what that's representing. So these are the new spots from these are the new locations from the shifted center. Okay, let's look at number 7. Okay, there's the y vertex at 4. There's the x vertex at 4. So the vertex is now at 4, 4. That's easy enough. Here's 0, 0, 1, 2, 3, 4, 1, 2, 3, 4. So there's the new vertex. Okay, we have a multiplier on the y's. Okay, the inverse of times 2 is times 1/2. So all of the y's are going to get multiplied by 1/2. It's going to be 1/2 as tall. So see, that number 2 means this shape is half as tall. Just like a -4 meant a shift of +4, -4 meant a shift of +4, a times 2 is a stretch of 1/2. Whatever's in the math, the picture is always the inverse of those numbers. Okay, so the vertex, I'm thinking of it as like 0, 0. And all of the y's are times 1/2. So these numbers right here are going to get halved. Well, half of 0 is still 0. Then I know I should have went 1, 1. Well, half of 1 is now 1/2. Then I should have gone -1, 1. Well, half of 1, the y, see it's only happening on the y's, is 1/2. Then I know the next one should have been 2, 4. But I'm having the y, so it becomes 2, 2. And the next one should have become -2, 4. So having the y is at -2, 2. So see, these we have to memorize. We have to know what should happen from the parent. And then, of course, I do know the next one. The parent should have been 3, and 3 squared is 9. So that's going to become 3, and then half of 9 is 4.5. And I know the next one, -3 squared is 9 again. So that one will be at -3, and then 4.5, and so on. So you can do as many as you want. So from the shifted center, I'm going to go over 0, up 0, so that stays the same. But then from the new center, I'm going to go over 1, up 1/2. So I'm going to go over 1, up 1/2 a unit. And then likewise, over 1, up 1/2 a unit. Now remember, we were going to, the normal one would have been over 1, up 1, over 1, up 1. So normally it would have been where the red was, but remember, we're only going to go half as tall. Okay, then normally in red we would go over 2, up 4. 1, 2, 3, 4. So over 2, up 1, 2, 3, 4. So the red one is the normal size. There's the normal width, the normal height, the red. But we're only going half as tall. So instead of going over 2, up 4, I'm going half as tall, over 2, up 2. Which is what this one says. Go over 2, up 2. And then the other one, left 2, up 2. And I think I'll go ahead and go one more. I'll go over 3, up 4.5. 1, 2, 3, 1, 2, 3, 4.5, right about there. Oops, right about there. So here comes my parabola. That number 2 right there made it half as tall. Remember that it's talking about y, so we're talking about tallness. Yes, it looks like it got wider, but really it's half as tall. It's rising at half the rate as the normal red one would have done. Okay, let's see if we can't. Now, yes, I want us to be able to go as quickly as possible. Okay, here's the vertex. The vertex is straightforward. It's the inverse. The inverse of +2 is -2. The inverse of -1 is +1. That's where it's going to start. So there's the vertex. Okay, the negative. So remember when we did a negative, just the negative flips it upside down basically. Instead of opening it up, it opens down. So that means it's going to open down. And 1/2, the inverse of 1/2, it's on the y, so all of the y's are going to be times 2. So it's twice as tall going down, starting here. So if I start at -2, 1, -2, 1 is right there. I know it's supposed to go, so the normal one would be over 1, up 1, over 1, up 1. And it would go from there. Okay, but with all of the shifting, It's going to be twice as tall, but going down. So instead of going over 1, up 1, I'm going to go over 1, down 2. Twice as much and upside down. Over 1, down 2. That's just doing it by intuition. If you want to do it by the numbers, we know 0, 0 should have been there, and then 1, 1 should be the next ones. So there's the parent numbers. The y values are going to get doubled and negated. So all of the y's, all of these are going to get multiplied by -2. So all of the y values are going to be times -2. So nothing happens to the 0, but 0 times -2 is still 0. But here, nothing happens to the x, but 1 times -2 is -2. So see, from the new center, we went over 1, down 2. So that's another, you can think of it in a mathy kind of way, or just a picture kind of a way. We're doubling the height. So on the red, I would have gone over 2, up 4. 1, 2, 3, 4. Well, doubling that is 8, but I'm going to go down. So from the new center, over 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. And over 2, down 8. And there's the graph with 5 points exactly correct. So I can now take a look. I can identify what this point is right here. This point from 0, 0 is at -4, -7. So I know what that point is. I also know what that point is. That point right there is at 0, -7. I know what that point is. That point is at -3, -1. So see, I can identify all of these values now just by intuition, because I know what these numbers are doing. Okay, so let's do number 9. Here's the vertex. The vertex is easy. The x part is +3, the y part is -2. Okay, 1, 2, 3, 1, 2. So right there's the vertex. Okay, I know all the y's are going to get multiplied by -1/3, because I need the -3 and the -1/3. If I multiply them together, that forces an inverse of +1. So it's going to be upside down and 1/3 as tall. So my 0, 0, all right, 0, 0. But the 1, 1 is now going to become 1. And remember, these numbers are getting multiplied by -1/3. So 1 times -1/3 is -1/3. So I know instead of going over 1, up 1, I'm going to go over 1, down 1/3. So here's my vertex. I'm going to go over 1, down 1/3. And then -1, 1 becomes -1, -1/3. So I'll go the other way also. -1, down 1/3. Okay, then the next point should have been over 2, up 4. But these numbers right here, the y numbers, and then also -2, up 4, the y numbers are getting multiplied by -1/3. So that makes this one become 2, -4/3, and -2, -4/3 from the new vertex. So that's sideways, it's down 1 1/3. So from my new vertex, I'll come over 2, down 1 1/3, over 2, down 1 1/3. Like that. Okay, so see what happened? It's upside down, and it's 1/3 as tall. Okay, so the last one. This is going to be, the y's are going to be 4 times taller, with the vertex starting at -4, 4. Okay, this is counting by 2, so -4, -4, -4, starting right there. Now, it's supposed to go over, no, these are counting by 2, so it's supposed to go over 1, up 1, over 1, up 1. It should go right there. And then it should go over 2, up 4, and over 2, up 4. So the red is what it would be if it wasn't stretched. But it's stretched times 4. So everything's going 4 times more than that. So instead of going over 1, up 1, I'm going to go over 1, up 4 times as much. So from this new center, over 1, up 4 is right there, and over 1, up 4 is right there. And then it should go 2, 4, but the y values are getting times 4. So that's going to be 2, that's going to go to 2, 16. Okay, so over 2, 4, 6, 8, 10, 12, 14, 16, way up there, and over 2, up 16, way up there. And there's the picture of that one. It's been shifted 4 down, 4 left, and 4 times taller. Okay, there we go.